So let's do this. Today we got Unit 3, Summarizing Quantitative Data. This is the start. Let's do this.
We will now begin our journey into the world of statistics, which is really a way to understand or get our head around data. So statistics is all about data. And as we begin our journey into the world of statistics, we will be doing a lot of what we can call descriptive statistics. So if we have a bunch of data, and if we want to tell something about all of that data without giving them all of the data, can we somehow describe it with a smaller set of numbers? So that's what we're going to focus on. And then once we build our toolkit on the descriptive statistics, then we can start to make inferences about that data, start to make conclusions, start to make judgments, and we'll start to do a lot of inferential statistics, make inferences. So with that out of the way, let's think about how we can describe data. So let's say we have a set of numbers. We can consider this to be data. Maybe we're measuring the heights of our plants in our garden. And let's say we have 6 plants and the heights are 4 inches, 3 inches, 1 inch, 6 inches, and another one's 1 inch, and then another one is 7 inches. And let's say someone just said in another room, not looking at your plants, just said, well, you know, how tall are your plants? And they only want to hear one number. They want to somehow have one number that represents all of these different heights of plants. How would you do that? Well, you'd say, well, how can I find something that maybe I want a typical number? Maybe I want some number that somehow represents the middle. Maybe I want the most frequent number. Maybe I want the number that somehow represents the center of all of these numbers. And if you said any of those things, you would actually have done the same things that the people who first came up with descriptive statistics said. They said, well, how can we do it? And we'll start by thinking of the idea of average. Average. And in everyday terminology, average has a very particular meaning. As we'll see, when many people talk about average, they're talking about the arithmetic mean, which we'll see shortly. But in statistics, average means something more general. It really means give me a typical, or give me a middle number, or these are ors. And really, it's an attempt to find a measure of central tendency. Central tendency. So once again, you have a bunch of numbers. You're somehow trying to represent these with one number. We'll call it the average. That's somehow typical or middle or the center somehow of these numbers. And as we'll see, there's many types of averages. The first is the one that you're probably most familiar with. It's the one when people talk about, hey, the average on this exam or the average height. And that's the arithmetic mean. So let me write it in, I'll write it in yellow. Arithmetic mean. When arithmetic is a noun, we call it arithmetic. When it's an adjective like this, we call it arithmetic. Arithmetic mean. And this is really just the sum of all the numbers divided by, and this is a human constructed definition that we've found useful, the sum of all of these numbers divided by the number of numbers we have. So given that, what is the arithmetic mean of this data set? Well, let's just compute it. It's going to be 4 plus 3 plus 1 plus 6 plus 1 plus 7 over the number of data points we have. So we have 6 data points, so we're going to divide by 6, and we get 4 plus 3 is 7, plus 1 is 8, plus 6 is 14, plus 1 is 15, plus 7, 15 plus 7 is 22. We'll do that one more time. You have 7, 8, 14, 15, 22. All of that over 6. 4, so this is also, no one ever did the universe and that just fell out of our study of the universe. It's a human constructed definition that we found useful.
You do? Exactly.
Now, there are other ways to measure the average or find a typical location, as say finding the circumference of the 4, and we could write this as a mixed number. 6 goes into 22 3 times with the remainder of 4. So it's 3 and 4/6, which is the same thing as 3 and 2/3. We could write this as a decimal with 3.6 repeating. So this is also 3.6 repeating. We could write it any one of those ways, but this is kind of a representative number. This is trying to get at a central tendency. Once again, these are human constructed. No one ever, it's not like someone just found some, religious document that said this is the way that the arithmetic mean must be defined. It's not as pure of a computation as, say, finding the circumference of the circle, which there really is. That was kind of, we studied the universe and that just fell out of our study of the universe. It's a human constructed definition that we found useful. Now, there are other ways to measure the average or find a typical or middle value. The other very typical way is the median. And I will write median. I'm running out of colors. I will write median in pink. So there is the median. And the median is literally looking for the middle number. So if you were to order all the numbers in your set and find the middle one, then that is your median. So given that, what's the median of this set of numbers going to be?
Right. He did. 3 and 6, so 18. 18. What's left? 4. So in there. 6.
Let's try to figure it out. Let's try to order it. So we have 1, then we have another 1, then we have a 3, then we have a 4, a 6, and a 7. So all I did is I reordered this. And so what's the middle number? Well, you look here, since we have an even number of numbers, we have 6 numbers. There's not one middle number. You actually have 2 middle numbers here. You have 2 middle numbers right over here. You have the 3 and the 4. And in this case, when you have 2 middle numbers, you actually go halfway between these 2 numbers. Or essentially, you're taking the arithmetic mean of these 2 numbers to find the median. So the median is going to be halfway in between 3 and 4, which is going to be 3.5. So the median in this case is 3.5. So if you have an even number of numbers, the median or the middle two, essentially the arithmetic mean of the middle two, are halfway between the middle two. If you have an odd number of numbers, it's a little bit easier to compute. And just so that we see that, let me give you another data set. Let's say our data set, and I'll order it for us, data set. But in this situation, it's like something very complex. But what we'll see is it's actually a very straightforward idea. And in some ways, it
0, 7, 50.
is the most basic idea. So the mode is actually the most common number in a data set. If there is a most common number, if all the numbers are represented equally, if there's no one single most common number, then you have no mode. But given that definition of the mode, what is the single most common number in our original data set, in this data set right over here?
It's 1.
Well, we only have 1 4, we only have 1 3, but we have 2 1s. We have 1 6 and 1 7. So the number that shows up the most number of times here is our 1. So the mode, the most typical number, the most common number here is a 1. So you see, these are all different things. This is used very frequently. The median is really good if you have some kind of crazy number out here that could have otherwise skewed the arithmetic mean. The mode could also be useful in situations like that, especially if you do have one number that's showing up a lot more frequently. Anyway, I'll leave you there, and the next few videos we will explore statistics even deeper. Find the mean, median, and mode of the following sets of numbers. And they give us the numbers right over here.
So the mean, you add them all over 1, 2, 3, 4, 5, 6, 7, 8, over 8. The median is, you have to reorder them, 23, or first 21, 23, 23, 29, 20, no, 20, no, before 29 there's 25, there's 29, there's 33, and then you take the middle one, and then the mode is 23, I guess.
So if someone just said divide mean, we want to average plus 25. 23 and 6. Divide center. The median, what we want to do is we go, there's 23. And no 24s, there's a 25. 25. There's 4, 5, 6, 7, 8 numbers. We already knew that. And so there's actually going to be two middles. If you have an even number, there's actually two numbers that kind of qualify for the close to the middle. And to actually get the median, we're going to average them. So 23 will be one of them. That by itself can't be the median because there's 3 less than it and there's 4 greater than it. And 25 by itself can't be the median because there's 3 larger than it and 4 less than it. So what we do is we take the mean of the 5, 24. Whereas the median is 24. One way of doing it. This is the middle. Think about them in this data. Because the number only shows up once, 23 is out.
Let's do exercises. It's ready. What is the median of the following? The median, we said we're gonna rearrange them. 5, 6, 6. How many data do we have? 1, 2, 3, 4, 5. So I got 5, and I got 5, 6, 6. The median is 6. Okay, what is the mean? Oh my god. The calculator, the mean is 1 plus 2 plus 10 plus 6 plus 4 plus 4 plus 6 plus 3 plus 1 plus 4. How many data sets do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, over 10. That's 41 over 10. That's 4.1. 4.1. Okay, what is the mode? The mode is 4, I guess. 4. Median 1, 1, 2. How many? 1, 2, 3, 4, 5, 6. So I got 1, 1, 2, 6. No, 1, 1, 2, 4. 2, 4. I got number 3 and number 4. That's 2, 4. That's 6 over 2 is 3. 3. The mean, I got 2 plus 4 plus 3 plus 6 plus 9 plus 4 over how many? 1, 2, 3, 4, 5, 6 over 6. It's 14 over 3, which is 4.67. 4.67. Okay. Do you have a next question? Okay. The mode is 1. The mode is 1. Okay. What do we have? Median. We have to rearrange the median. Fucking ridiculous. 4, 5, 5. How many sets do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So we got 9. Starting with, so we have to go 9, that's 4.5. That's number 5. That's number 5 because number 5 there is 4 before it. So number 5 is got 4, only 1, 5, 5, 7. That's 4, 8. I got 8 is the median. Okay. Calculating the mean. Should we? Article calculating the mean. We know the mean by drawing a picture of each person. Okay. Then each took the same number of cookies. Each girl would have 4 cookies, so the mean is 4 cookies. What did you say? I'll show each person and their cookies. Imagine that the girl combined all of their cookies, then each took the same number of cookies. We can think of the mean as the number of cookies each girl would have. They were equally distributed among the 4 girls. Find the mean number of bananas. Okay, 1, 2, 3, 4, that's 4. And 5, that's 9. And 3, that's 12. So I got 12 banana over 12. How many is it? 1, 2, 3, 4. Over 4, that's 3. 3 bananas. Okay. Find the mean of the data. So I got 2, 3, 5, 9, 14, 18. 18 over how many data sets? Over 6. That's 3. Wait, why? What? Yep. 2, 3, 5. So where did I go wrong? I got 3 and 2, 5 and 4, 9 and 5, that's 14 and 4 and 4 is 18. 18 over 6. It's not okay. So I got 18 over 6 is 3. What are you talking about? 2 plus 1 plus 2 plus 4 plus 5 plus 4. 18. How many data sets do I have? 1, 2, 3, 4, 5, 6. 6, that's 3. 3, what are you talking about? It's 3. Add up all of the data points. Oh, add up 18. He's not asking. Okay. How many data points are in this? 6. Okay. The mean of the data set is 3. Okay. Now time to try some practice. The mean of the data set. 5 plus 23 plus 8 plus 12 over 4. 12. Okay, I got 2, 7. Find the mean. 2 plus 7 plus 5 plus 4 plus 6 plus 3. Okay, how many data sets do I have? 6 over 6. That's 4.5. 4.5. Okay, I got 4.5 plus 5 plus 3.5 plus 2 plus 2.5. Okay, 1, 2, 3, 4, 5 over 5. 7 over 2, which is 3.5. 3.5. Okay. Practice. Oh my god. Calculating the mean, calculating the median, choosing the best measure. Let's practice. Okay, number of spells. Find the mean number of spells cast. Okay. 10, 12 over 4, that's 3. 3 spells. What do you mean? Okay. Find the mean distance. Yeah, 3, 5. Well, I got 8 and 5, that's 13, and 3, that's 16. 16 over 4. 16 over 4. 4. Am I right? 4. Yep. Health point, the mean number of. Well, 43 plus 57 plus 30 plus 18 plus 26 plus 12. 186. 1, 2, 3, 4, 5, 6 over 6. That's 31. Okay. Uh, I got practice when she found that 7 practiced for 30 minutes. Lee Min practiced for 45. Wendy practiced for 90 minutes. Thomas practiced for. Gabriel practiced. Find the mean length of practice time. So I got 30 plus 45 plus 90 plus 75 plus 60. And how many data sets are 2, 3, 4, 5? Oh my god, over 5. That's 60 minutes. Now the show of 60 minutes. Okay, calculating the median. The practice, calculate the median. So I got sort the data from the least to the greatest. Sort the data. So I got 1, 2, 2, 4, 4, and 9. Find the median. 2, 3, 4, 5, 6. 2 plus 4 over 2. That's 3. Okay. Sort the data. 2, 3, 3, 3, 4, 5, 7, 8, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I got number 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Number 4. Sort the data. I got 14, 14, 15, 17, 22, 1, 22, 23. 1, 2, 3, 4, 5, 6, 7, 8. 8. So I got these two. 17 plus 21 over 2, 19. That's a 19 students. Okay, sort the data. We got 15 first. 15 over 2. Then you got 12. You got 12. Then you got 17 here. Then you got 18 here. Okay. 1, 2, 3, 4, 5, 6, 7. So 7, the middle is this one. So it's 17. The median. Okay, choosing the best measure. This I might find. Okay. Mean and median both try to measure the central tendency in a dataset. The goal of each is to get an idea of a typical value in the set. The mean is commonly used, but sometimes the mean is preferred. The mean. A golf team's 6 members had the scores below in their most recent tournament. Okay, below this is the scores. Calculate the mean. What is the point of this? Okay, the mean is 70 plus 72 plus 74 plus 76 plus 80 plus 114. So that's over how many? 6 data sets for 6, 81. The mean is 81. Okay. Okay. What is a correct interpretation of the mean square? It is the well, in the set of scores. That is, have the team scored higher than the mean and half the team scored lower than the mean. What? It represents the average score. If each golfer had scored the same, they each would have scored the mean. Yeah. Okay, find the median score. So the median would be 6. So I got 76, 75. Median is 75. Okay, which measure best describes the score of the team? That goes almost all of the scores. Well, the median best describes the scores of the team because the mean is higher than almost all of the scores in the datasets. Okay. Mean, median, and mode. Mean, median, and mode are different measures of center in a numerical dataset. They each try to summarize a dataset with a single number, a typical data point from the dataset. The average number found by adding all data points and dividing by the number. The mean, we know what the mean is. The median, the middle number found by all data points and picking out the one, the middle, or if there are two middle numbers, the mean of those two numbers. The median, because when the numbers are put in order, the number 4 is in the middle. The most frequent number is, okay, the mode, highest number of times. So the mode of is 2 equals to occurs 3 times which one. Okay, no need. Calculating the mean, there are many different types of mean. Usually when people say mean, they are talking about their mean, we know this. Okay, example, practice problem. Okay, it's the mean, Khayyim. What is wrong with you? 10 plus 6 plus 4 plus 4 plus 6 plus 4 plus 1. That's 35. 1, 2, 3, 4, 5, 6, 7. 7. That's 5. That's 5. Okay. Finding the median. Okay. Okay. So we have 4, 5, 5, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. So we got 8, and the mode is 8 here. Finding the mode. The mode here is 4. Okay. Is there anything? The modes most commonly occurring data. The mode is useful when there are a lot of repeated values and can be no mode, one mode, or multiple modes. No miss. Okay. Quiz 1. What do you think? Tomorrow, I'm summarizing quantitative data. I think we did a lot today, huh? In statistics. Okay, was arithmetic mean. Got 8 plus 1 plus 2 plus 6 plus 1 plus 4. 22 over 6. 6. Okay. 3.67. Okay. Mean, also mean. Okay, 41 plus 38 plus 36 plus 57 plus 43. That's how much? Over 5. That's 43. It's 43. Okay. And I got 15, 11, 9, 12. Okay. The median is 15. No, it's 15 plus 12 over 2. So there are 6. 1, 2, 3, 4, 5, 6, 12. 12 plus 15 over 2. That's 13 and a half. 13 and a half. What? The median. Okay. What did we say? 15 plus 12 over 2. That's 13 and a half. What are you talking about? The median number of composites. I got 9, 11, 12, 15, 17, 18. Still the same. 1, 2, 3, 4. 15. What are you talking about? The median. 9, 11, 12, 15, 17, 18. Where did I go wrong? 1, 2, 3, 4, 5, 6. 6, so 3, number 3 and number 4. What are you talking about? That's 12 plus 15 over 2. 13.5. What are you talking about? What are you talking about? Talking about? I don't know. That's the median. Data point. Where did you go wrong? 13 plus 0.5. It is the mean. Don't fuck with me. What the fuck has happened? What did I put in the first place? What the fuck is wrong with you? Okay. 28, 26, 24. What do you want? The mean? 26, 28 plus 26 plus 24 over 3, 26. It is also the median. Huh? No, the median would be, well, it is the median. What do I know? What is this? 26. What is wrong? Okay. We're gonna have to repeat this one. The mode is 10. Let's do it again. Quiz 1. Quick. No. Let's do quiz 1 again. Oh my god. Why are you doing this to me? Try again. Okay. Median. 2. And then I got 6, 7, 9, 11, 14. 1, 2, 3, 4, 5, 6, 7. So 7, I got 1, 2, 3, 4. Number 7. Okay. Mean. 47 plus 35 plus 32 plus 41 plus 30 over 5. That's 37. 37. Okay, median. Are you for sure? So I got 3. How many is this one? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I got number 5. So I got 3, and then no. Got 1, 2, 3, 4, 5. Sure. Okay. The mean. Okay. Listen to 17 items were seen on 20 on Thursday. 19. Okay, so I got 17 plus 20 plus 19 plus 29 plus 31. 1, 2, 3, 4. No, wait. 1, 2, 3, 4, 5. Over 5. 23.2. Am I correct? 1, 2, 3, 4, 5. 23.2. Okay. So what is find the median? Find the median. The median I start 1, 2, 3, 4, 5, 6. So I got number 3 and number 4. So 1, 2, 3, 4. Yep, I got 5 and 12. That's 17. 5 plus 12, 17, 2, 8.5. 8.5. Don't fuck with me. Now, 1, 2. 1, 2, 3. That's 3. 4. 4 is 9. 5 and 9. That's 14. Sorry, 14 over 2. 14 over 2. 14 over 2. 7. God damn it. Try again. I'm not. Nah. Okay. Ready to practice? What do you mean? Two more on median and mean? Oh my god. I guess we'll leave this till tomorrow. That's it will be for today's statistics and probability.